Hey everyone, it's December 24th, 2024. While everyone else is getting ready for the holidays, we're diving into some really cool AI research.
Always got to stay ahead of the curve, right?
Exactly. Today, we're taking a deep dive into self-evolving training for multimodal reasoning.
Multimodal reasoning.
Yeah. So it's all based on this research paper, and basically, it's about AI that can learn how to reason like us. But here's the kicker. It can even handle different types of info at the same time, like text and images.
Hmm.
That's the multimodal part.
Ah, I see. So like how we process information from the world around us, not just words, but what we see too.
Exactly.
Yeah.
It's the kind of AI we need for like super intelligent robots, the ones we always see in movies.
And self-driving cars that actually understand what's going on around them, not just reacting to the data.
Right. But the researchers, they point out that this whole thing, making AI that can reason with multiple types of data, it's really hard.
Yeah, definitely. I mean, think about it. We don't even fully understand how our own brains do it, right?
Exactly. And that's the problem. We don't have enough examples of human thought processes to train these AI models on. It's like trying to bake a cake with only a picture of the finished product, no recipe.
Makes sense. We need a way for AI to learn how to reason without us giving them step-by-step instructions for everything. And that's where this self-evolving training comes in.
Okay, self-evolving training. So the AI is basically learning from its own mistakes, kind of like practicing and getting better at something, but without someone constantly telling you what you did wrong.
That's a pretty good way to put it. It's all about letting the AI learn from its own output, not just relying on humans to label everything. We give it tools and a sandbox to play in, and it figures things out on its own.
Okay, I'm kind of getting it. But how do we make sure the AI builds something awesome in that sandbox?
That's the key question, right? And this research, they actually break down three main things that affect how well this self-evolving training works. First up is the training method.
So like how often and in what way the AI gets to practice, right?
Well, exactly. Do we train it in batches? Let it learn continuously. Turns out the best way is what they call continuous self-evolving.
Continuous self-evolving. So
Yeah.
like a constant flow of learning and adapting.
Think of it like a river, always moving, always taking in new information, and refining its reasoning as it goes. No strict stop and start learning here. Makes sense, doesn't it? If you want the AI to be able to handle the real world, you got to teach it to adapt on the fly.
That makes a lot of sense. But how does the AI know if it's on the right track? Like how does it measure its own progress? Isn't that where the reward model comes in?
You got it. This is where things get interesting. You see, typically we might reward an AI just for getting the right answer.
Like giving a dog a treat when it sits.
Exactly. But these researchers, they took a different approach. They created something called a process reward model, or PRM.
So instead of focusing only on the outcome, the PRM looks at how the AI got there. Like it's not just about whether you won the game, but how you played it.
That's a great analogy. The PRM actually looks at the quality of the AI's reasoning steps, not just the final answer. It's like evaluating a student's work based on how well they show their work.
That's fascinating, and it makes a lot of sense. It's about encouraging the AI to develop solid reasoning skills, not just getting lucky with the right answer.
Exactly. It's about nurturing the AI's ability to think critically, even if it makes a few mistakes along the way.
Okay, so we've got continuous learning and a reward system that values the process, not just the outcome. What's the third factor they talk about?
This one's called prompt variation, and it really made me think. It's all about what kind of questions we give the AI to learn from. Do we just stick to questions with clear right answers, or can we throw in some open-ended ones, even if WE don't know the answer?
So like giving it problems that require it to think outside the box, even if there isn't a clear solution.
Right. It's a bit of a gamble, and the research shows it can work, but only under certain conditions. The AI really needs a solid reward model, like that PRM we talked about, to navigate those uncharted waters. Otherwise, it might just end up going in circles.
So it's like we can give it a map with some blank spots, but only if it has a really good compass.
Exactly. Now, before we dive deeper into how the AI actually learns, I want to touch on something you mentioned earlier. These AI models, are they all those massive supercomputer-sized things?
That's a good question, because I know some of these AI models are huge GE. Did they only use those for this research?
You know, that's one of the things that surprised me. They actually tested this on a range of models from 2 billion to 8 billion parameters. So yeah, some serious computing power was involved, but...
But they weren't all mega-sized.
Exactly. And the fact that this approach worked across different sizes is really important. It suggests that this isn't just a solution for super advanced AI. It could be applied more broadly, which is pretty exciting.
That is exciting. It means we could potentially bring this self-evolving learning to all kinds of AI, not just the giant ones.
Yeah.
Well, hold on, before we get too carried away. Okay, so we've talked about the AI learning in its sandbox, but where does that sandbox come from? Like, what are they actually using to train this self-evolving AI?
So they tested it on all sorts of stuff, but the main training ground was a data set called Math V360K. It's this massive collection of text and images specifically designed for multimodal reasoning.
Math V360K, huh? So they're basically throwing math problems at this AI and seeing how it handles them.
You got it. But it's not just equations, it's like word problems, diagrams, all sorts of stuff that really tests the AI's ability to reason with both words and pictures.
And they split this data set into like a training set and a testing set. So the AI learns on one part, and then they see how well it performs on the other part that it's never seen before.
Exactly. But they also wanted to see how well this self-evolving AI could handle a totally different challenge, so they brought in another benchmark called Math Vista.
Math Vista, that one sounds familiar. I think I've heard that it's pretty tough, like the AI Olympics or something.
That's a great way to put it. It's like a gauntlet of multimodal reasoning tests, everything from visual question answering to solving geometry problems. If an AI can conquer Math Vista, you know it's got some serious reasoning skills.
So how did this self-evolving AI do? Did it win the gold medal?
Well, hold on. Before I give you the results, there's one more thing I got to tell you. They did this really clever thing to make the AI more receptive to self-evolving training.
Really? What'd they do?
So they noticed that most AI models, right off the bat, they try to jump straight to the answer, like a student who just writes down 42 on a math test without showing any work.
Uh-huh. Yeah, I've definitely known a few students like that.
Yeah.
But how do you teach an AI to show its work?
That's the cool part. They have this warm-up phase where they give the AI problems with known answers and make it explain its reasoning step by step, kind of like giving it training wheels before it takes off on its own.
Ah, that's pretty smart. So they're basically teaching it to think through problems before they let it loose to evolve on its own.
Exactly. And once the AI had this basic chain of thought capability, they could really start experimenting with different self-evolving training methods.
And I bet that continuous self-evolving approach we talked about, combined with that fancy process reward model, PRM, really shined, right?
Galileo. But let's talk about that PRM for a second. I know we touched on it earlier, but how did they actually build and train this thing? I'm still a little fuzzy on the details.
Yeah, me too. It sounds super complex, like something out of a sci-fi movie.
It is pretty complex, but I think I can break it down. Basically, they trained another model similar to the main one, but with way more training time.
So they're like creating a super smart teacher model to train the PRM.
You got it. And this teacher model generates tons of solutions to problems, right and wrong, and each step gets a quality score. Then they feed all that data to the PRM, teaching it what good reasoning looks like.
So the PRM learns from the best and then guides the student AI to follow in its footsteps, like AI mentorship or something.
I like that. But there's a catch. Even with all that effort, the PRM wasn't perfect, especially when dealing with questions that didn't have a clear right answer. Sometimes it struggled to tell if a solution was actually correct.
So it wasn't a foolproof system, but didn't you say it was really good at ranking different solutions?
You remember, that's where it really excelled. Even if it couldn't always tell right from wrong, it could consistently pick out solutions with the most logical and relevant reasoning steps.
Gotcha. So it's like a wine expert who can identify a high-quality wine based on its subtle nuances, even if they don't know the exact vintage.
Now you're getting it. So yeah, the PRM wasn't perfect, but it was a pretty darn good guide for this self-evolving AI. But here's where things get really interesting. They didn't just stop at developing the system. They wanted to see how the AI's thinking actually changed as it evolved.
It's like how its brain was actually adapting and learning over time.
Yeah.
That's wild.
Right. They call it the dynamics of learning, and it revealed some really fascinating insights. As you might guess, as the AI got better at solving problems, it also became more efficient.
So it was finding the right answers faster.
Exactly. But they noticed a potential downside. The AI also became less adventurous in its thinking.
So like that student who memorizes all the formulas but forgets how to think outside the box.
Exactly. It was so focused on getting the right answer quickly, it kind of lost its creative spark.
So how do you fix that? How do you encourage an AI to be more adventurous in its thinking?
Remember that temperature setting we talked about? The one that controls how creative and random the AI can be?
Oh, yeah, right. Was that the solution?
You bet. They found that by adjusting the temperature, they could nudge the AI to be more playful, to explore different approaches, even if they weren't the most efficient way to get to the answer.
So, like giving it permission to color outside the lines every now and then to see what happens.
Exactly. And get this, they actually developed a way to adjust this temperature automatically, so the AI could maintain that balance between exploration and efficiency throughout its training. Pretty cool, huh?
That's amazing. It's like they've created an AI that can learn and grow just like a human student, with all its quirks and creative impulses.
And that brings us to the culmination of their work, the M-STAR framework. Remember all the key ingredients we've discussed: continuous self-evolving training, the process reward model, prompt variation, and this dynamic temperature adjustment. All of that comes together in M-STAR.
So it's like the ultimate recipe for self-evolving multimodal reasoning. But did it work? Did this Frankenstein's monster of AI actually live up to the hype?
Well, let's just say the results were pretty impressive. M-STAR consistently outperformed other approaches, not just on MATVista, but on a whole bunch of other benchmarks like M3COT, MM-STAR, MM-Bench, and AI2D.
Wow, they really put it through the ringer. So this wasn't just a fluke. It seems like MSTAR can really hold its own against the best of the best.
And the fact that it works so well across all these different benchmarks with different sized models, it's incredibly promising. This isn't just some niche solution. It could potentially change how we approach AI development across the board.
Okay, I'm officially on the MSTAR bandwagon. But even the coolest research has its limitations, right? What were some of the challenges they encountered?
One of the biggest ones they highlighted was finding really good data to train that process reward model. Remember, garbage in, garbage out, right?
Yeah.
If the PRM is trained on bad data, it can't effectively guide the main AI model.
So even with all this cleverness, they were still limited by the quality of the data they had access to.
To some extent, yeah. They managed to create a really good PRM for their experiments, but they acknowledge that finding even better data is crucial for pushing this field further.
It's like they've built a supersonic jet, but they're still using regular old gasoline.
Haha, I love that analogy. And there's another challenge that comes with all of this, and that's the computational cost. Training these large AI models, especially with all the fancy features of MSTAR, it takes a lot of computing power. It's a resource-intensive process.
Yeah, 8 billion parameters, continuous self-evolution, a separate model for the PRM. It's like trying to run a marathon while carrying a refrigerator on your back.
Haha, yeah, something like that. It highlights the need for finding more efficient training methods. If we want to make this technology accessible to more researchers and developers, we got to lighten that load.
It's a challenge for the whole field of AI, really. As these models get bigger and more complex, we need to figure out how to make them more sustainable.
Absolutely. And this research is a great example of why that's so important. They've achieved something truly remarkable, but it comes at a cost.
Well, we've covered a lot of ground today, from the nitty-gritty of training methods to the philosophical implications of AI that can learn on its own. But I think the biggest question is, where do we go from here? What does this all mean for the future of AI? What does it mean for US?
That's the question, isn't it? And that's exactly what I want to explore next.
Okay, so we've explored how this self-evolving AI works, but the big question is, what does it all mean? Like, where does this lead us?
That's the million-dollar question, right? For me, the most mind-blowing thing is that we might be on the verge of creating AI that's not just solving problems, but actually learning and adapting, getting better on its own, almost like it has its own internal drive to learn.
It's kind of like, is this how we accidentally create Skynet?
Yeah.
But seriously, what are the real-world applications here? Beyond self-driving cars, what could this kind of AI unlock?
Well, imagine AI that could design even better AI. It's like a self-improvement loop that could accelerate progress exponentially. Think about problems like climate change or personalized medicine, things we haven't even scratched the surface of. This kind of self-evolving AI could be the game changer.
All right, I'm sold. Sign me up for the MSTAR future. But hold on, this research was all about text and images, right? Could this work for other types of data too? What about audio or video, or even the data coming from all those sensors around us?
That's a great question, and the researchers actually touched on that. While they focused on text and images, they think the core principles of MSTAR could be adapted for other modalities. Of course, it'd be more complex. You'd need to tweak the reward model, the training methods, all that stuff to handle different types of data.
So it's not a one-size-fits-all solution, but the potential is definitely there.
Exactly. It's like they've cracked the code for how to make AI a more independent learner, and that opens up a whole world of possibilities.
It's pretty mind-blowing stuff. But we've been geeking out about all this cool tech for a while now. Let's bring it back to our listeners for a second. What are your thoughts on all of this? Does this make you more excited or more nervous about the future of AI? If you could talk to these researchers, what would you ask them?
Those are the questions we all need to be talking about. AI that can learn on its own raises all sorts of ethical and philosophical questions about control and even the very nature of intelligence. It's not just a conversation for scientists anymore.
You're absolutely right. This is about shaping the future we want to live in, and it starts with understanding what's possible and what we need to be careful about.
Knowledge is power, especially when it comes to something as powerful as AI.
Well said. And on that note, we've reached the end of our deep dive into the world of self-evolving AI. Hopefully you enjoy this little holiday brain teaser.
Definitely food for thought.
Who knows what amazing breakthroughs are just around the corner. But until then, keep exploring, keep asking questions, and most importantly, keep that sense of wonder alive. Happy holidays, everyone.
Yeah, happy holidays.